Hello there. Welcome back to my regular stream. Later this week than it has been. I normally try and go out on Tuesdays, but today it's going out on Friday. Just life things. Life things getting in the way. But we're here and we're printing and we've got some modeling to do. So firstly, welcome. Let me just set a couple things up first. Do bear with me on my usual unprofessional stream intro. So, yes, we can begin. I've got my tea and I'm ready to go. The technology is working more or less. Today's print, we just take a look at the printer view, is looking pretty messy. Hopefully we won't need to stop it. But I've had some issues with it already this afternoon, and I can see there's some loose strands of filament waving away there in the build chamber. Not looking ideal. But I think sometimes these things are best left to see how they turn out. It's a Christmas ornament. It's a little decorative ornament piece for our Christmas tree. And just wanted to test out how the print would come out. And also decorate our tree at home. So it's a little Christmas ornament. Doesn't particularly matter if it comes out flawed, because it's just for us. Part of the reason why I've been having issues with this print is because Bamboo Labs have refill filament. So the filament that you normally get comes on a spool. But if you want to save a bit of money and save a bit of waste plastic, you can buy the material on its own and replace it onto the spool. Much like how if you've got a sewing machine, you might be able to rewind the bobbin. You know, you can put the material back on the spool. You can do that with this material, but I wasn't following the instructions properly. So when I put it on, it started to unwind, and that's causing tension issues with the material as it's loaded in the printer. So every now and again, it's been jamming and stopping, and I have to run out and unjam it. And that's probably part of the reason for the poor quality print today. We'll see. We'll see how this goes. It might fail again as we're streaming. But that's how it goes. This stream is all about process. It's about failure. It's about how we're actually working, turning up each week, trying to make progress. So today's oh no, before I get into today's thing, a couple weeks ago I modeled a funnel for a gutter, and the gutter hopper has been printed and fitted. So I thought I would share the video that was shared with me, just quickly showing the finished article. There it is. It's been printed and installed. So yeah, just a little hack to try and fix a gutter problem, and our design has been put in situ. So there's some continuity for you, some modeling from the other week, being printed and installed. But this week, I'm going to go back to the ongoing project of a bespoke design for a side table. This is the model, 3D model, of this enormous, large wooden reclaimed table leg that I found being thrown out. Really heavy, it's really big, and I want to do something with it. So this kind of almost 17th, 18th century looking carpentry, I'm going to 3D print a kind of tabletop to go on it, and make a sort of unique one-off piece. So that's what this model is. We got it into CAD so that we can then start to get a sense of the proportions and get a sense of what needs to be done. But now what I'm going to do is not model the tabletop necessarily, but model in Grasshopper the kind of structure that I want to use. If you go onto my website, alexkimberdesign.co.uk, you'll see one of my products that I've designed before, which is very organic and very almost looks like the inside of a bone or like a root structure or something. So I want to try and use that same process for this design. So just to give you a sense of what I'm going to be doing, you imagine, I don't know how visible that line is. Look in the notes there. You imagine this is the tabletop, and this is the top of the wooden thing. You know, the wooden thing is coming down like this, and same on the other side. It's just sort of continuing on like that. Then what I need to do is basically fill the structure between the top of the table leg and the underside of the tabletop surface. So that's what I'm going to do. I'm going to fill in from that kind of void there, and I'm going to use Grasshopper. The first thing what we're going to do is I'm going to start by rotating this around. You know what? I'm going to copy that over. We're going to zoom on that one and rotate this one just to keep the space. Do a 3-point rectangle and just kind of get a that rectangle. if it's planar, meaning is it flat? I think it is. I'm not going to be too panicked if it's not, but I think it is. So that's flat. This square is going to work as the kind of starting point for our model. I'm going to bring it in here. I'm going to have a little curve placeholder, and I'm going to set one curve. So that is now baked inside Grasshopper. Remember, things that happen in Rhino is slightly different to things that happen in Grasshopper. They kind of interact, but they're also a little bit different. So in order for this data to carry through, I have to set it. I have to say, right, this is now linked to that curve in Rhino. So let's link to that. Now, it's going to be quite hard for me to explain in advance what it is that I'm going for here. So I think you're just going to have to, you know what? No, I will try and explain, because otherwise it's going to be very difficult to follow along. I find my old, I know how I'm going to do this. I'm going to pull up an image of one of my old designs, the design that I'm imitating, so that you can see what I'm going for. So this is one of the chairs that I designed. I'll pull in another one. Yeah, so I'm trying to recreate this very organic structure, but this time with a sort of hard tabletop. And yeah, this kind of structure is what I'm going for between the wooden chair leg and some kind of tabletop. So I'm going to use Grasshopper, show you how I came to this. That's what I'm doing. You can kind of see how this is quite difficult to explain with words. So let's carry on. I'm going to start by populating to depopulate. So this is going to add a random number of points, well, a number of points in a region. So it's populated that. Let's go to don't like that green on green. Let's change the view. Surfaces. Change the color. Right, it's a bit darker. It's fine. So what this is doing is it's populating an area with a load of points, and I can use those points to construct the various structs and nodes that I need to make my structure. So I can manipulate how many points I want. I actually happen to want just 4 for the base, but I can have more or less, and maybe 4 or 5, some amount. The next input is the seed. That's just it gives you like a new option. So this is randomly generated. But I can choose which kind of variation. By moving the seed, I kind of pick and choose new variations of that randomly generated series of points. So I can add more or less points like this, and I can change which permutation of points that way. So far, so good. Now, what I then want to do is work towards the tabletop. So we're going to create, that's the rectangle. And we're going to take I need to find the center of this curve here, the top of the table leg. So we're going to do a curve, we're going to area function. The area function also has an output for the center. So I can put that center into there. That's going to give us the rectangle, really small at the moment. And I want it a 300mm square. Oh, it's put it on the corner like that. Fine. Fine. Move. Remember, area also gives us the center. Move this geometry from 2 point vector to point. So I want it to move from A to B, and that's the translation vector. Take that rectangle and move it to the middle. Hide that, don't need it anymore. So also hide that point, don't need it. Hide that. And I want to, firstly, let's keep things organized. Let's move that input over here. And then this lot, let's create a little group. Call it tabletop generation. Try and keep tidy as we go forward. Move again. We're going to move the tabletop up. So I want a Z vector. And this starts off as a unit vector, meaning it's a unit of 1mm in this case. This is going to give me a little bit of height. Vary that. 50mm should be fine for now. Let's call it height from leg, just to be specific. And then we can hide that one, and this is the tabletop that we're working towards. Now, why have I been specific about 300 millimeters? That's because I was looking up the safety standard for tables, the European standard for testing furniture. And the 2023 variation of the standard, I can't remember the number, allows for what they call delicate tables or lightweight tables, which are ornamental side tables which are not intended for heavy functional use, and it's limited to a 0.3 meter square area tabletop maximum. And this classification of delicate table has a lower testing standard, so it's not intended for heavier use. There's still safety requirements, but by making it a smaller table, a side table, only intended for coffee cups or whatever, the testing requirements are less stringent to allow for that. So I'm going to try and keep it within that limit for my obviously quite decorative side table. So I'm just having a think about how we're going to do this. I think I want to do it in discrete bands, discrete layers. So I think there's a way of tween curve. Here we go. So tween, if you've ever done some animation, is kind of blending one curve into the next, but I don't want to use the word blend because that has a technical definition here in Grasshopper, but essentially you're transforming one curve into another. I want to tween, between, get it? The top first curve and our tabletop, and that's created this thing, this middle step. Tween factor. Oh, so is that the distance? I presume that tween factor kind of at what point it's blending by. Yes, yeah, okay. So you can kind of see what's happening here. Oh, it's giving it a bit of a twist as well. That's interesting. I don't know if I want that. Maybe I do. Let's leave it in for now, but I can see that it's twisting in a way that's unintentional. Now, is there a multiple tween? Because I don't want like just the one. Can I do multiple factors? Zero 0.25, 0.5. Yeah, there we go. So you see what's going on here? We're blending from one curve to the next, and I'm doing it at the kind of quarter way, halfway, and 3/4 way points. And presumably because of the way that the computer has sort of numbered the corners, it's actually rotating it. I didn't plan on that, but I'm going to keep it in for now, and I can change it later if I don't think. Fine. Now what we're going to do is populate 2D curve. This is putting out three different I'm gonna have to think about. Okay, I'm gonna continue modeling this in such a way that we're constrained to 1, 2, 3 steps. But if we wanted to change the number of steps, the way that I'm about to do this might then get more complicated down the road. But for now, and you'll see why. But for now, we're just going to assume this is how we're doing it. Make progress. So I'm going to list item. I'm going to take that list. I'm going to remove the first item. I'm going to use that as the region. Why are there points outside the region? That's funny. How is that? For what I want to do, this isn't going to affect me too much, but that's really interesting. I don't know how it's done that. I presume what it defines as region is just kind of define a rectangle that defines the 2D region for the point. Oh, it's literally just drawing a box around the shape and then filling that with points. Fine, it works for what we're doing, but it's odd. Now, I'm going to come up with a new number called factor. I'm just going to call it factor. This is how many branches each layer is going to add. So this first set of points, I said, has a count of 4. So there's 4 points in this starting layer. The factor is going to multiply the original count with the number of new branches that I want. And then I'm going to put that in the new area. And what we're going to try and do is link the points from here to here. And we're going to do that again and again and again until we have a crazy looking structure. Let's see how we go. Nearest point. Find the closest points in a collection. Find the closest point in a number of closest points to find. There we go. So the number of closest points to find is going to be the same as the factor. And the point to search from is going to be the first layer. And the cloud of points to search are these. So now hopefully the data that this gives so you see how this data is kind of split. What this is saying is that for every point in the first layer, the next closest 2 points in the second layer are this point and this point, and then this point and this point for the first point layer, this point and this point for the first point, and so on. And if I increase the factor, and then that's going to increase for every first point on the first, every point on the first layer, the next 3 points on the second layer are these. That's what this list of numbers is saying. 2, I think, will be. Now I know this is not going to include all the points that are generated, because there's going to be multiple so some points on the second layer are going to have more than 2 struts going to it. If I were being super strict, I would try and find a way around that. Again, for the sake of progress, I'm going to accept that as fine, that we're just going to try and progress this. So what we now need to do is draw some lines. Draw some lines from the bottom layer to the second layer. How are we going to do this? We're going to do line A and B from those points. Is it just going to work if I do that? Kind of. Yeah. I need to graft that. Yep. There you go. That's looks a little bit sparse, so I think what we're going to do is bump that factor up 3. And move the seed somewhere. There we go. I think that'll do for now. So can you kind of see what I'm building out here? For every point on the first layer, it's linking up to the next closest 3 points on the next layer. And I know that there will be enough points on the next layer because the maximum number of points will be multiplied. It will be the same number as before, but multiplied by that factor. So there will be enough points, but it's also missing some points because of the way that it's randomly distributed. It won't necessarily be the case that every point on the next layer will be reached. Now, as I said before, if I was being a purist, I might want to do something about that. But today we're just going to try and push forward and get something going because these problems can be fixed. Talking of problems being fixed, I've only just noticed that the printer stopped printing. Let's take a 2-second pause while I fix that. Okay, hopefully that's going to continue. As I said, yeah, it's because of the way that I wound up the material from before. So back to our project. You can see how this is building up. Let's do the next layer before I then make this 3-dimensional. So now what we can do is essentially repeat this process. I'm going to hide okay. Let's call that first layer points. Then let's select those and call it second layer points and struts. Should we be technical and fancy and call them nodes? Let's use the correct kind of language. Nodes. Node's a funny word. Node. This is table top heights. Layer generation. Right, getting organized. This is good. So, essentially what we're going to do is copy this whole thing. Copy all of these. Let's rename that appropriately. Third layer nodes. And then let's bump that up to 1. So this is now selecting that next layer. Let's hide that because it's getting distracting. So what we want to do is take this number, which is the number of points that's going into the layer below, and we're going to multiply that by the factor. Let me just remind myself where the factor is going. Okay, that's the factor there. We're going into B, so we're going to put that into A. And then if I view that, we've got a whole load more points or nodes in that next layer. Excellent. Preview the nearest points. Let's look at the lines. Aha. So this is taking the lines from the bottom. We don't want to do that. We want to take these points and stick it in there. And then I want to, for data reasons, which I can't be bothered to explain, I'm going to ungraft that. Trust me, it makes sense. Does it now? Does it? Oh, no, it doesn't make sense. What we want is, okay, I need to inspect the data. So what is coming out of here? Like we saw earlier, points to search from. Okay, So I want to move those points into here, points to search from, and I want to flatten it. Again, just trust me, that's what I want to do. Why is that going crazy? This is saying every point on that draw a line. Okay. I'm now trying to think about the data flow of this so it makes sense. Because it's looking like there's too many struts coming from each node, or at least some of the nodes, so I need to know why that is. So what is going on here? Got my list of points from before. I flattened it. So that should be just a list of 12 points. Points to search from. So for every one of those points, we're searching this cloud what the closest 3 points are. That's generating this list of points. It says 11, but that means 12 because the first one starts at 0, just the way that the computer thinks. So for 12 points, we've selected the nearest 3. Excellent, that's what I want. So from A, which is the points below, grafted to B, does it need to be grafted? What if I flattened that? Looks even worse. Alright, well, the observant among you will have noticed that the print has stopped again. So, I think I'm just going to need to rethink that. The filament is jammed or something. So, I'm not going to keep replaying. What I'm going to do is just stop the print. That's been stopped now. That's a shame, but you know, we learned something. Okay, so back to this. Looking crazy. Why is it looking crazy? Should it be going in the other way around? No, that is the right way, from A to B. Hmm. Oh, okay, I think I know. I think I know what I need to do. Flatten tree. And then I need to graft it again from there. There we go. The reason why I needed to do that is because if I just put it back to how it was a second ago, you see here it says 0, 0, 0, n equals 3, 0, 0, 1, n equals 3. That's telling me that the number of items in each level is 3. There are 3 items in each level. So as we can see from this one, there are 4 kind of levels, and under each level there are 3 items. So remember, each of these sections are the first layer of points. So from the first layer of points, the next closest 3 are those 3, and again and again. So this is listing 12 points because it's 4 times 3. But the way that the data is organized is in groups of 3. What I need down here is the data to be organized in groups of in 12 groups rather than in 4 groups, so that when this data matches it, it slots in properly. So but what I can't do, I can't just flatten it here, because that's just going to give me a straight list. That's just going to give me a flat list. Flatten tree. Show you what it looks like. This is just a list of 12 items in one layer of data, right? So this isn't so much 12 items. This is 4 lists of 3 items, right? This is one list of 12 items. That doesn't work for me either. What I need is essentially 12 lists of 0 items, if that kind of makes sense, so that I can then merge them correctly with the next bundle of data. So I'm going to put that in there, and then I'm going to graft it up. Now, if that doesn't make sense to you, don't worry about it. This has taken me like a long time to get an intuitive sense of how this works, and I still am really slow and have to think about it. But here we go. So we've now got 2 layers of struts with a kind of exponential effect, right? Where from the first layer, we started off with 4 points, and we're growing up by that factor. Now, to give you something interesting to look at before the end of this, stream, what we're going to do is make this 3-dimensional. So first I'm going to increase the height, not because I want it that much taller, but to make it, that's going to be quite a tool thing. So I'm doing this just for visual effect. I'm then going to do a multi-pipe. Multi-pipe is a great function in Grasshopper, one of my favorites. Now, if I just put those curves in, and no, this isn't going to work. Curve. Well, it would work, but it's going to be neater this way. Let's put all these into here. Let's flatten it to make one long list. Stick it there. Look at what we've made. Crazy structure. Crazy organic structure. Okay, we need to change this to control. Crazy organic structure. Blop, 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 blop. What I want to do, still got a few more minutes. Let's see if I can do it in time. I want to have the thickness increase over time. So how am I going to do this? If you're supplying multiple radii for node size, these points identify which node to set as which radius. If only some nodes have their radius, then the values will be interpolated across. What I want to try and do is have the struts nearer the bottom to be thicker than the struts nearer the top, and then they get thinner and thinner as they go up. Right now, as I change the node size, they all get thicker. And I kind of want the bottom ones to be thicker, and then they get thinner and thinner as they get nearer the top. So what we do, I wonder whether it's going to map. You know what, let's just quick. So this is taking the end points of all these curves, so all the points that are basically in use, being used by those curves, sticking points on there. Now let's take placeholder for points, start points and end points. So all the start points and all the end points. How's this? If you're supplying multiple radii node size, these points identify which node to set which radius. Only some of the nodes have their radius set. Values will be interpolated across. How do I know what number the nodes are at? This is probably not. We can't just name the point. I do though. And then those. You know, I'm gonna have to figure this out later. But this is how far we got. So let's leave that at a now, and let's save that. My project code number. Okay. Generation. Okay. Oh, so that was tonight's stream. I'm glad that I got the structure modeled, or at least started. It's feeling reminiscent of when I designed those chairs and all of the head banging with grasshoppers, trying to figure out how to get all the structs and meshes to work. It was a really complicated grasshopper file that took months to get right for those tables. But this has been fun. Try and get back to that. Hopefully, after a couple weeks, a couple more of these sessions, we'll have a bespoke design ready to sell. Wouldn't that be interesting? Shame about the print, but you know, these things happen. 3D printing is not always as consistent, and I think I know the cause of it, so this can be wrecked. All right, peace out. See you next week.